Hi, Sean Collins here, going to record a video to get you ready for the first lab for patient-client management that you'll have with me, but it'll also help prepare you for upcoming labs with both Dr. Duffy and also, again, with myself. In the lab, you're going to be getting a mouthpiece that has a tube attached to it, and it's essentially a place for you to put your mouth. It's not very fancy. It's very cost-effective, actually. And a place for you to put your mouth, and then two one-way valves. One of these one-way valves allows you to breathe in, and one of these one-way valves allows you to breathe out. So when you're doing most of the testing, we'll have a nose clip. I just forgot to bring it from the lab. So I'm just going to show you me breathing through this, and you may be able to see condensation building up on the inspiration, expiration ports as air flows in and flows out. So we've got inspiration, expiration. Now we've got this cap, and on mine it has my initials so that I don't forget it's mine. And incidentally, you'll get one of these during the semester, and it'll be your responsibility to hold on to it, clean it any way you want. Soap water's fine, alcohol preps are fine. The only part you really need to clean probably is the top part here, because you don't really breathe in and out of this thing. Although you do push pressure in and out of this thing. So because we have a cap, we can cap off either inspiratory and then only get expiratory flow, or we can cap off expiratory and only get inspiratory. And when we cap one off, if we cap off inspiratory, when we attempt to breathe in, the negative pressure of our attempt is, because of this valve, is diverted down the tube into whatever device for monitoring pressure we put it into. So if we block off the opposite end, if we block off expiratory, then we can breathe in, but when we try to expire, the positive pressure we generate will go through this tube instead of the expiratory port and go into whatever device it is that we're using to record. So I'm going to just show you how using it's a magnehelic gauge is what they're often called, and this one here is calibrated to centimeters of water, which is done with a manometer. So you may hear people refer to it as a manometer. Technically, a manometer literally measures the amount of centimeters of water in a tube against gravity that are moved. So it's exactly the same approach to measuring pressure of millimeters of mercury. Instead of mercury, you have water, and instead of millimeters, you're looking at centimeters, which are both metric system digits, so they're really easy to convert. So here's my magnehelic gauge, and you can see on the face of it, and you'll see it better when you get it in person in lab, we've got pressure and vacuum. Pressure is for positive pressure, vacuum is for negative pressure. So I've got this set up blocking the expiratory port, so I will not be able to expire through it. The expiration will generate pressure, and it will record here. So this is how, in lab, for the first week, we will do a standardized Valsalva maneuver in order to measure blood pressure response as described in Chapter 10 of the Cahalan book and on the handout that I'll give you. So again, we're going to have a nose clip on, and then you're going to do a Valsalva maneuver, but only to 40 centimeters of water. Or we could convert, it's a 1.36 is the conversion factor between centimeters of water and millimeters of mercury. So incidentally, we can also use this to measure the negative I mentioned. So I'm going to flip the port over and then just show you quickly, once I get the tube all plugged in, that I can measure the strength of my diaphragm or whatever inspiratory muscles you're using. So to really, just like any manual muscle test, just like any muscle testing, you have to watch form to know exactly what muscles are being used. So we'd have to watch the form to feel more comfortable that the diaphragm is what was being used to generate that pressure. If you see a lot of sternocleidomastoid and scalene contraction, then you may not be getting a diaphragm contraction. But we can also show you how you can palpate just around the ribs to sort of feel for whether the diaphragm is contracting or not. So we'll do that later in the semester. But for this first week, you're going to get comfortable with your new mouthpiece. I just want to show you really quickly that we could also use a blood pressure monitor. So this is popped off of the tubing of a blood pressure monitor. And I'm just going to pop, it's not made for this, so the tubing is a little bit less compliant for this device than the rubber for the blood pressure cuff tubing. But you can generate a vacuum, or we can pop this around, pop the stopper around, and generate pressure. In 2005, 2004 or 5, Larry Cahalan and I actually did a small lab study where we had about 150 measurements performed with one mouthpiece going to 3 different devices, and confirmed that the estimates of vacuum, even though they're negative, and you have to subtract from 320. If you go from 320 to 260, you have to know that you've just gone 60 millimeters of mercury and then convert to centimeters of water, which is the most common unit used for respiratory muscle isometric pressures. But it actually is quite accurate. We presented it at an APTA meeting, I think in 2005. So we'll probably talk more about that later in the semester when we start talking about patients that you might have that you might consider doing respiratory muscle testing on, because it's very uncommon in PT for whatever reason, and it's not that complicated to do. I mean, yeah, it's not as uncomplicated as manual muscle testing, but you do get quantifiable numbers that have a very small standard error of measurement and can be tracked and looked for changes over time. So we will talk more about that throughout the semester. I just wanted to give you a heads up about the mouth guards and the mouth the mouth pieces that we'll be using, so that tomorrow in lab we don't have to spend as much time talking about them. Thanks.